Hey guys, welcome. It's time for TechWise TV. I'm Rob Boyd.
And I'm Jimmy Ray Purser.
And today we are talking about something called multi-gig, which sounds a little marketing-ish.
Yeah, of course, yeah, absolutely.
Here's what struck me about this as we started getting into it. The premise being that we are now literally looking at the very near future, and by very near future I mean, in other words, in this year, we are looking at a level of wireless access that now exceeds the speeds of the cable that connects to the wireless.
Isn't that crazy? Isn't that the most absurd thing?
It makes no sense because the whole paradigm is, where do you go if you need bandwidth? And reliable, where do you go?
Find the wire.
Find the cable, right?
Yep.
This was a new problem to me when we started getting into this, and so I'm curious, from your perspective, is it really a new problem? Did you see this coming? I mean, does this make sense? Are we making something up and then solving the problem?
Well, not necessarily. It does make a lot of sense because when you look at where we've came from, let's take a look here at the board. When you look at where we've came from and stuff, back in '97 when the FCC opened up what they called the ISM band, the unlicensed frequency, and said anybody can use that, the IEEE came out. Well, you know what, even before that, NCR and LSI came up and they said, why don't we make a wireless technology? We'll call it Waveland, and it's going to be like 1 meg, 2 meg, and we're going to make it for cash registers.
We'll never need that much.
You know?
Yeah,
exactly. And it evolved and to 802.11, and the guy who ran that, Vic Hayes is considered the father of wireless. So, I mean, if you ever get a test question on who's the father of wireless, Vic Hayes is the guy. He ran the 802.11 for 10 years and is really considered the real driver in that. But as we've progressed down to standards and stuff, or how this works, is, oh, you want to get a picture of Vic?
Yeah, sorry.
He's a great guy, man, if you ever see the guy. But standards started evolving from 97 to 99. We went from 802.11, just having an interest committee, and then right into A and B, you know, kind of came around, obviously, pretty darn close to the same time.
Is this the scale? Yeah, I'm looking because it looks like you purposely, I'm assuming you drew this.
Yeah.
It looks like you're drawing.
Yeah, it is. But yeah, it is just for
So a little bit more distance, 99 to 2003, a good 4 years.
And one thing, here's something I want to mention real quick, just kind of an IEEE pet peeve of mine. Because a lot of people call these things like A, they'll say, oh, do you support the A standard or the B standard?
Yeah, what's wrong with that?
That's not correct. These are amendments. You can always tell in the IEEE amendments are lowercase. The standard is always this. It's 802.11 or whatever it is, dash that year. Everything else in here that's rolled in the standard.
So this is a standard, and these are all amendments to that standard.
Amendment to that standard.
Well, I'm getting to you that in multiple ways.
So yeah, that's
okay.
So a lot of people will say standard, and it's not wrong, you know, to say it that way. But just so you know, the more you know. But
sounds like a good bar bet.
So we went 10 years
to the next standard.
We jumped up to the next standard here, and what this is called a roll-up.
Why are we so hung up on the 11?
11 is the frame type itself. So you have 802 is 1980, February of 1980 is when the communications piece happened. .1 is LAN side. .3 is Ethernet. You know, .5 is token ring, that type of stuff. .11 is wireless. And so that's really
never going to change as long as it's still wireless.
It's locked in. And so you actually set, okay, .11 is going to cue in right away. That's always going to be wireless. 2007 is the standard. And when you see them rolled up like this, is what you call a roll-up, where they take all these changes that have happened, all these amendments, and they roll up into one master standard. Okay. Because when you want to progress, everything is based upon this last roll-up.
Okay.
So the standards were rolled up in 2007. And then in 2009, we came out with 11N. So look at our distance here.
Yeah, this was a long period of time, and now we're starting
to close the gap up. This is where the key to understanding what MGig really does here, right? Is that because we're making such fantastic and fast progress, I mean, you go over here from the thought being 1 meg, 2 meg, you know, and then down here being 11, and then up to 50, and then now you're over here to 11N, and we're starting to pick up more speed, more capacity, more ways of multiplexing that signal out. We did a roll-up standard again in 12 to include all our basic amendments to that. This was 13 is when the AC standard came out.
Only a year.
Isn't that amazing? From the roll-up to here to here. That was when AC came out, and AC was a massive game changer. Remember we did the fundamentals on that? And it was incredible, which won an Emmy Award. Or got nominated, didn't win, but yeah, it's still pretty cool.
Details.
Yeah, and so the
amendment standard.
So this came out in 13, which is kind of the newest and latest and greatest. And then what you're looking at is saying, wow, man, look at the progress we've made from here. And now, what do we got in the future? Well, in 16, we're expecting AH and AJ to come out, and then actually even to basically what's going to be the replacement for AC, which is AX 4 times the speed of what we're getting. We are planning for M-Gig right now for AC Wave 2. And then we're thinking in 19, we're looking at going 4 times this speed.
And AC Wave 2 is coming within the year, from what we can tell.
But look at how quick the gap is. That's the key. Is look how compressed your timeline is getting as we go on. And the advancements are unbelievable. I mean, you're really, I like to compare wireless to almost like flight. You know, the Wright brothers designed flight, and Orville Wright watched an Apollo mission take off. That's incredible.
Got to see that level of progress. Yeah, from nothing before.
Yeah, from nothing. And so you're seeing this happen right in front of you, which is unbelievable.
So is it correct to say that in the wireless space, we are innovating faster as an industry than we are in the physical cable space?
Oh, by far.
Okay. I mean, just make sure that's not.
Absolutely.
And therein lies the challenge, right? Is because one is eclipsing the other. But the point is wireless never remains wireless throughout the entire chain. It has to hit cable at some point, and if that cable can't keep up, therein lies the problem.
There's a problem. Then you're wasting money, is what it really amounts to. Your people are wanting something, and you're wasting money. If you can't actually take advantage of that speed, you're throwing money down the toilet, and that's crazy. And nobody's going to want to upgrade a cable plant to do so many speeds. It's going to be crazy. But the reality of it is that you don't have to upgrade your cable to take care of this M-Gig stuff. Keep it in mind, though, because around 19, we're looking at AX. We're wanting to go 4 times faster, and you're going to have to look at doing a cable plant upgrade, because we're going 4 times faster. We're going to need.
Yeah, you're going to.
It's just the reality of it. So, you know, if you're planning,
but at least it's not tomorrow.
It's not tomorrow.
If you're building something new, you better be thinking about it now.
There you go.
Excellent. Well, we got a lot of show. We're going to cover this and how to answer that issue.
Yeah.
Bring up the problem, solve the problem. That's how it works? Something like that?
I like that. I like how that works.
I like that. Okay, guys. Hey, it's going to be a very busy show. We've got a couple of key things to talk about. Specifically, it's multi-gig. Yes, that's what the whole show is about, because wireless is indeed getting faster than cable, and it's happening faster than you would think. To do that, we've got some switches. We've got new products to talk about. We're going to talk with the product managers and the engineers that are developing these things for us. But first, we're going to talk about how Cisco is working to bring an entire group of people together, an entire industry, through an alliance to make sure that this stuff is going to work for you with the stuff you already have and with the stuff you're looking to do in the future, with the cabling that you have right now. And that is part of our work with the Nbase-T Alliance. We've got a surprise guest that I can't wait to show and bring on to Jimmy Ray. All that's coming up next.
Peter Jones, what's up, man?
Jimmy Ray, how you going, man?
Holy smoke, what the heck are you doing here?
You asked. Of course I came.
That was my Oscar moment. I was trying to act. Hey, man, it's great to have you on the show, especially to talk about M-Gig and basically Nbase. That's what we really want to cover. And you're the chair of the Nbase Alliance.
Yeah, I got it. That's my job at the minute.
Well, let's go back from the beginning then. So does this slide here sum up why Nbase came into existence?
Absolutely right. So there's a bunch of reasons, but the key one we can see here is basically what's happening with wireless, right? So what you're seeing on this slide is basically the chart of wireless bandwidth over time.
Okay.
So you can see it's a nice chart. We've got the high, we've got the max, we've got the low, we've got the mid. This is the important number. This is 1 gig.
Okay.
Right, so what you're going to see here is clearly wireless has gone beyond 1 gig as a backhaul from the AP to the wireless switch. So we've got to solve that problem.
So right here, what we're actually covering, you got, and we're seeing this right now because now we're up going to 50. Okay, all right. And was it AC that actually pushed that a little bit higher?
Yeah, that's clear what's happening. You'll see this over here where basically we see the trends of where we're moving to.
Okay, all right, very good. And the second bullet kind of catches me too. The AP upgrade cycle is faster than switches or cabling. I guess that makes sense.
Well, if you think about it, right, it's pretty easy to plonk a new AP up.
Yeah.
Right, replacing your switches, right, you know, like 5 to 7 years.
Configs and all that crap, yeah.
Pulling a cable.
Yeah.
You want to recable a building? We see like 10 to 15 year lifetime on that.
Yeah, oh yeah, cable plants last a long time, don't they? That's true.
And so the other thing to think about is, if you want to avoid the Ethernet being the bottleneck, you need to be doing 75% of the radio speed.
75.
Yeah, that's about the number everyone agrees on.
Now the solution that Nbase has came up with is 2.5 to 5 gig over Cat5e?
Sure, that's the goal.
What determines the speed here?
There's a whole lot of reasons for that, but those are the speeds that are just basically really easy to do.
Okay.
So what we're looking at is saying we're basically taking 10Gbps PHY technology, we're running it at either half or quarter speed.
Oh, okay.
So this gives us a whole lot of viability, right? Because if you think about 10Gbps, currently it only runs on Cat6a. We need to run on 5e and 6 because that's what's in the walls.
Okay.
So what we're looking at is we want to basically leave your cable there because that's the thing that's in the walls you don't want to touch. Change your AP, change your switch, get your speed upgrade. So the whole goal here is to make sure you can deploy 11AC Wave 2 easily and basically support all your new needs for your workspace.
Huh. I don't know if this might take us into a completely different area, but running a 10 gig PHY at half or quarter speed, surely that doesn't just solve that problem. There's got to be some more stuff on the back end as well.
There
right?
are some interesting other problems, because if you think about it, the reason that you can't run 10G-based-T on 5E today is that basically the channel isn't that good.
Yeah.
And so some of the stuff that's interesting is to try and make sure that you can run these signals correctly without running into too many errors.
Okay.
And that's where some of the interesting technology is coming up.
Okay, very good, good stuff. Now, and this is what you were seeing right now, 5x speeds without replacing any cabling infrastructure. Pretty darn impressive improvement.
It's very good.
I mean, when you're talking about return on investment, if you're able to get 5x on anything you spent 10 years ago, that's pretty darn good return on money. I mean, that's good stuff.
Yeah, no, it is really good. And as you see it there, we're supporting the PoE standards as well.
Oh, very good. Well, that's definitely in the bonus land. So a couple weeks ago, did a podcast, and I mentioned about doing this show. And quite a few of the comments was, this is silly. Why would I ever go from 1 gig to 2.5 or 5? Makes no sense at all. I'll just jump up to 10. Why wouldn't you use 10?
So the basic problem for 10 is installed base cabling.
Uh-huh.
Right, if you go look at the surveys today, it looks like about 75% of the cable that will not support 10G-based-T for 100 meters. Right, so what you're seeing over here is Cat 5e is about 46, Cat 6 is about 28.
Wow.
So if you think about how to do this deployment, right, I want to deploy 11 AC Wave 2 APs fast, right, going and telling people to recable their buildings, it's a hard roll.
Well, it's amazing what a stalwart Cat 5e is, isn't it? I mean, that has been out for a long time.
The one other point I want to make is that going straight to 10G-based-T, right, our APs can't support that either. If you think about an AP, it's a pretty small device.
Yeah.
Right?
Yeah.
Plain and rated, got to go on a duct. You don't want more power in that thing than you can avoid.
Yeah, because you got to worry about shedding all that stuff off later, right? Interesting. Very cool. Very cool. Okay. And that takes us to Nbase. This is where I really want to dig into, because a lot of this stuff, obviously, you can read on data sheets and all that stuff, but it's very rare that you have the chairman of an alliance committee sitting here right in front of you or standing in front of you. So
I feel special now.
Yeah, well, you should, man. This is pretty cool. And I'm just glad I got to interview not Rob, because Rob's usually like, no, we don't need a goober. We need a real host. So the Nbase Alliance itself, founded in October of 2014 by basically what we're looking at here is these four dudes, these alliance members here at this cut line. These are the folks that founded it, right? Cisco, Aquanta, how you say it? Aquantia, okay. Freescale and Xilinx. These are the people who founded this alliance, and then of course more people are joining, that kind of stuff. Did everybody kind of come to the consensus at the same time and say, this is a problem?
I think what's happened is that everyone, over the last year, it's become blindingly obvious to everyone. And so you can see, we have a good representative of people across the industry joining, right? These are not small companies, and we're getting bigger companies coming through.
Yeah.
So it becomes very clear that we have to solve this problem for our customers, right? And so it's just one of those inflection points where the industry is all deciding, hey, it's time to move.
You're not necessarily a standard, you're more of like the Wi-Fi consortium, right?
We're similar to that, right? So the basic goal is we're not writing a standard, right? Because that's a standard, that's a job for IEEE.
Right.
So what we do is we agree a specification. We'll make sure that we can define interoperability between member companies, and then we'll go and try and build industry consensus around our specification.
Okay, very interesting. Now, are you guys the only player doing something like this? I mean, something has this kind of money on the table. There has to be more opinions here.
There are other people in the same game, right? And they basically have the same goals.
Okay.
Right. So as I said earlier, we're getting to the stage where once you make the story and you make it clear, I mean, if we show that chart about the AP speeds and 1 gig, everyone goes, got it. So the speeds of APs and install-based cabling, once you explain that, the need is clear. So we're not the only people in the game.
Are we going to have, VHS and Betamax wars here? How's this going to play out for, me?
There are no sure things in standards, but what is clear is that we're getting a very clear message from the industry that this is something we need to get done fast and clean and soon.
How fast?
That gets hairy.
Okay.
Right, 2 years maybe?
Really? No kidding.
So the real question is, when's the last technical change? And for that, we need to build industry consensus.
Okay.
I mean, that's the way the standards work, is you don't work by asserting I'm right, you basically get everyone to agree.
That's right.
So our goal is to go out and build a viable ecosystem and become the clear leader in having the right solution.
Okay, that makes sense.
Then the standard will fall through.
Now, what would be, as a chairman of Nbase, if I'm wanting to think about my company kind of being part of this and maybe saying, I don't know, man, what's your overall objective?
So what we'd explain to people is that we believe we have the solution which meets the needs of customers. We have a specification available today, we have parts available today. So we believe we have the viable solution that solves the problem and is available.
Okay.
So we would ask people to join us and come and basically push our standard forward.
And that's the whole objective that's the vision statement of Nbase.
Yeah.
Well, son of a gun. Well, this is pretty good stuff, and it's certainly going to be really interesting watching how this stuff shakes out. You guys got a website and stuff too that people
Absolutely.
can go and follow the progress and all that. What Nbase.com?
Nbase-T.org.
Oh, Nbase-T.org. Well, that's easy enough to remember. Okay, well, man, Peter Jones, this is so freaking cool, man. It's so great to have someone that's actually right in the forefront of pushing this standard. So thank you so much, man. I really do appreciate it, man.
Thanks for your time.
Peter Jones.
Hassan, thank you so much for joining us. I never get over the excitement of getting to deal with something that feels like it's a disruption in the market. And we're doing something new, we're doing something different, and it feels like we're on the front edge of something here. And there's nothing I respect more than the Catalyst switching line. And I would not do it justice to describe exactly what you're in charge of. But you're here because we wanted you to be able to reflect some of those changes and how they're reflected in multiple families of Catalyst switches. Is that accurate?
Absolutely, Rob.
Tell me, what are you responsible for? What do you and your team do?
So basically, I am responsible for product management of the Catalyst switching portfolio, which is the Cat 2K, 3K, 4K, and the 6.
Just those little lines.
Keeps me busy.
Say. Yeah, okay. Yeah. Well, now, so when it comes to multi-gig, which I know is just a factor of what you do, is because you're looking at taking, is it something in every one of those lines into this new era of gigabit support?
So multi-gig is something that we are going to have almost across all the access product line, right? Because that's where the technology is relevant. And as you mentioned, right, it is one of the biggest disruptions that is going to happen in access switching in probably a decade. And we started on this journey about 2.5 years ago when we started looking at what was happening with the proliferation of mobile devices. Right? We talked about the Cisco VNI data, which talks about in 2018, mobile data traffic will be more than 30 exabytes. Massive. So a bandwidth tsunami is coming. There are standards in the wireless world, 11AC, 11AC Wave 2, 11AD, 11AX.
Yeah, these things are growing faster than we've ever seen before, and as a standards body, it feels like wireless is growing faster than even the rest of the industry, but that creates this cascade effect that you guys are working to address?
Absolutely, right? So how do we keep up with it? We talked about unified access at your show, and we launched converged access, which talks about how do you distribute wireless on the switching infrastructure to massively scale this. But now the next question is, how do you address the bottleneck that we are going to see between the access points and the switches themselves, right? How do you move away from 1 gig? How do you move towards a speed beyond that? 11AC Wave 2 is the big application for this, which talks about 6.9 gigs of theoretical bandwidth, 5 gigs of aggregate bandwidth. So really the speed between the access point and the switch has to go beyond this 1 gig.
So what goes into making a decision about how you guys are going to address this? Because we have to make early decisions. I mean, you talk about 2.5 years ago. I mean, you have to take a lot into consideration. You have no small installed base, and we're certainly not going to be conceding any installed base going forward. If anything, of course, we're all expected to grow that. How do you decide what to do and what not to do?
Some questions that can come up is like, look, speed transition, why don't we go to 10 gig, right?
Yeah,
it's an obvious question. The servers have gone there. And really, when we looked at this problem, we looked at 10 gig as a technology. But as you mentioned, we looked at our install base. And we looked at the install base, and mostly the dominant portion of the wiring is Cat 5e or Cat 6, right? Which does not support 10 gig, right? So we wanted to give this investment protection.
Okay.
The second thing is the big application I talked about are going to be wireless, the access points. Most of them are powered over Ethernet.
10 gig and PoE don't dance right now.
Exactly,
Yeah,
right?
okay.
So we had to make them dance. And so that was the problem that we gave to our engineering team. Give us a solution which...
Here's your constraints. Here's where you need to be. Okay.
Go beyond 1 gig, 2.5, 5, and even 10. Give us support for PoE, PoE+, universal power over Ethernet. Make it work on existing cabling infrastructure, right? We challenged the laws of physics here, but the engineering team made it happen.
So tell me, from a product support, paint me a picture of what are we looking at in terms of new products coming out to support this? How's it going to work into existing infrastructure for people who've recently made investments? What's the plan there?
Yeah. So, Rob, we refreshed our Catalyst switching portfolio in the last 12 to 18 months, and we have talked about that on your show. And we are really building on that. So, firstly, what we are introducing are 2 new SKUs on the Catalyst 3850 family.
Okay.
The great thing about this is the 3850 has been shipping for more than 18 months. This new family of M-Gig switches is going to stack with the existing 3850s, right? So it's same software, same stacking mechanisms, so everything will work together, right? Secondly, we introduced the 4500 and the SOUP 8E on your show as well, and we have now introduced support for converged access on that platform. And we are introducing a new line card, which is an M-Gig line card for that platform. Again, complete investment protection, right? You don't need to change the supervisor, just put the line card in and you will be able to connect these new access points or other 10 gig devices that you need to. Lastly, we are also introducing a family of compact switches. And one of the compact switches is going to have mgig support, right?
Okay.
We are seeing a lot of people look at workspace transformation, and we see compact switching playing a big role in this workspace transformation projects, and mgig is going to be a big part of that.
Excellent, excellent. Well, San, I'm anxious to dive into the details. I can see Jimmy Ray is getting prepped to want to take back over the lab area here and get into those details, so let's move on to that. San, thank you so much.
Thank you, Rob.
Jenkar, welcome to TechWise TV, man.
Good to see you, Jimmy Ray.
Even better to see you, especially bringing all this cool-looking gear, man.
Yeah, man.
So you're here to talk to us about mgig?
Yeah, the new Cisco multi-gig technology that we have.
That sounds a little marketing-ish to me. What the heck is that stuff?
The multi-gig technology is like the coolest innovation that we have from Cisco. You know, really like squarely addressing the wireless explosion, right? The bandwidth tsunami that we've been having. You know, this product line is the new mgig technology is going to help our customers to squarely address this.
So real quick, mgig, that's the 2.5 and the 5 gig stuff, right?
And just not that, the mgig ports are also capable of 10 gig up to 10 gig speeds.
That's pretty extensible PHY then. Okay, so that being the case, what type of cabling are we going to need to achieve that kind of stuff?
The cabling on the mgig, we can support the Cat5e cabling, which is predominantly out there in the industry.
Right.
According to our estimates, over 75% of the cabling out there is estimated to be like the Cat5e cabling.
Okay.
Right. So there are some deployments with the Cat6, and most of the newer deployments are Cat6a cables. But if you are looking at the limitation of these cables, right, so the Cat5e cable is capable of only supporting up to 1 gigabits of speeds.
Right.
So if you are looking to leverage the Cat5e cabling with any of the technologies that's out there in the field, they cannot scale beyond 1 gigabits of speeds. Whereas with the new mgig technology that we have, the same cable can be reused by deploying this technology.
Okay, let's introduce everybody to this, some new gear here and stuff. You've got my favorite switch here, which is the 4500. You've got some 3800s here for the stackable side of the house. What'd you bring for us? New line cards?
Yes, on the Catalyst 4500, what you're seeing is the Supervisor AT, which is the where we introduced the converged access, right? So, and what you're seeing, the blue line card out here is the line card that's capable of supporting the Cisco multi-gig technology.
It's the blue under here is what you're actually showing how
That's right.
That's the indicator that these are mgig ports.
Yep.
And that's you're carrying that through across the entire product line, right? From the chassis, stackables, even little compact switches and stuff. These are all carrying that little blue tag, so you know that they're mgig ready or
That's
mgig
right,
supported.
Jimmy.
Okay. Then let me ask you. So now we're looking at this on a 4500. This is a new line card. What kind of restrictions do I have on supervisors?
The mgig line card can be used on the Supervisor AT, which is the newer supervisor.
Okay.
And it is also supported, by the way, on the Supervisor 7E and the 7LE, which is predominantly out there in the field.
Yeah, no, the 7 I see all the time. That's great news. That's really good news. So now then we jump up from the 4500 to the 3800 here. Obviously, this from the back of it, a standard stackable switch. No big surprises here and stuff. But I think the thing that while the mgig stuff is certainly the flavor of the month, one of the things that also surprised me is, what do you got over here?
Oh, those are, so basically you're looking at like the downlink speeds as they are going beyond 1 gigabits of speeds.
Yeah.
The uplinks are also, guess what? The uplinks are also like, going to become more and more bandwidth hungry.
Right.
So for that, we're introducing 2 new uplinks here. The first uplink is a 2x40. So this is going to support the native QSFE. Right, so you can plug every single QSFE that is out there in the field on these switches.
Even like the BiDi stuff that they use on the Nexus? Will
yes,
that fit in
we are
What?
planning for a support for that. Yeah.
Son of a gun. Okay, and then obviously these are the 10G.
Yes, those are the 8x10 SFE plus ports. So we have so far supported either the 4 or the 2. Now we're introducing the doubling the number of uplinks that can be supported on this, up to 8 ports of uplinks.
That's some good link capacity right there.
Yeah.
That's good stuff. Okay, really cool. Gosh, what some nice add-ins. So then let me ask you this. So when you're looking at the mgig type of technology, it's great that we work with the mixed supervisors here, from the 7 to the 8. But I'm a little concerned on a stackable switch like this one and stuff. How does it work in a mixed stack? Does that kind of exclude what I want to do? So do I have to have all M-Gig switches in a stack, or can I mix and match?
No, absolutely not. So that's the beauty of this solution, right? So as you're introducing the M-Gig, so this is like any other 3850 switch.
Yeah.
So you can, if you're having an existing stack of 3850 switches, you can, populate these, like, add more to your stack to increase, like, the capacity to introduce the M-Gig into your stack, or you could, have standalone stacks as well. So it's the same software, which is capable of supporting the M-Gig as well.
That's very cool. So now, and even when we're looking at some of the power requirements and stuff, I'm assuming PoE, PoE plus, also UPoE, will that work on the M-Gig stuff?
That's right. So every single M-Gig port is capable of supporting PoE, PoE plus, UPoE. That is 15,
60 watts,
30,
that's some
or
good
60
juice,
watts.
man.
Yeah.
That's good stuff. Yeah. Wow, that gives us a little more flexibility now, doesn't it? And the reason for this is because of the AC Wave 2, right? I mean, that was a real motivator to wanting to come out with something like this. It wasn't like a bridge standard to make people who couldn't go from 1 gig to 10 gig to make it cheaper or something. It was truly, the first thought was for the AC stuff.
That's right.
Okay, very cool, very cool. It's amazing how we've advanced in technology that the wired link is now going to become the bottleneck of the network, isn't it? I mean, how many times do I remember going into the office and saying, well, I can't download this video on wireless, and let me find a hard line and plug it in. And now it's just the opposite, or will be.
Right.
Very, very cool stuff, very cool stuff. So let me ask you this here. So what changes as far as how I manage this switch? I mean, because now I've got, some different speeds, some different capabilities on here. Does my management change at all? Or is it just physical layer, get over it?
If you're running your existing software, you just need to upgrade to the next version of the software that is capable of supporting the M-Gig. But it is going to be one single software that you traditionally use, right, on these switches. So there's no change from a management standpoint.
The standard wireless tools, all that stuff, they're not going to balk and see this up speed as kind of like an unknown baby giant or anything like that. It's going to be like, it's fine, everything's cool. The engineers out here watching the show, they really want to cut through all the marketing mess, find out what they really need to know. What's the real scoop on this? And just a little bit of time, what would you say is the real scoop on M-Gig?
So taking it beyond 1 gigabits of speed on your existing cabling.
Yeah.
And not only that, I just also wanted to introduce to you before the newer compact switches.
Yeah, that compact switch is pretty cool. We didn't have enough time to talk about it because got the 4500. That's good stuff.
Yeah. Basically, on these switches, so you're capable of taking up your switches on your existing software to speeds beyond 1 gigabits of speeds.
Yeah.
You're running the same software, so running the same CLIs and all the command sets, the coolest stuff that you had on the Cisco switches for a very long time.
Very, very cool stuff. Well, Shankar, this is really pretty cool, man. I'm really wanting to take this stuff out and actually plug it into the TechWise rack here and see what we can do to get some performance testing done. Thanks, dude. I really do appreciate it, man. I really like this. This is all right.
So here's the question. I was just, we were just talking about, I love listening to you and Peter Jones just go deep into some of the background, and you get into the physics that's involved here. And that's really what I started wondering, which is, as we look at what we are now able to do, as it seems, increasing the ability to get more out of that Cat5e cable and extend the life of that cable plant, why can't we continue to do that? I mean, what's the limiting factor in just being able to, why do I really need to upgrade it in the next 5 years? Can't I just wait for more technology to be invented? Or is there
eventually you bump up to a limit that's controversially called the Nyquist-Shannon theorem.
Nyquist-Shannon theorem.
But it's also called Nyquist-Shannon, and then some Russian name, and then a German name behind that, because it was two guys who came up with this theorem that basically said that you're taking a discrete operation in space and you are converting it to a numerical sequence.
Okay.
And there's a limit of what you can do when you're actually making this conversion process. So you'll hit a limit of what you can do from in space to actuality and practice. And so you'll bump up against what's called basically the Shannon limit when it comes to actually pushing this stuff through the cable.
Isn't that where it came about? Because I think I remember reading what you had told me you wanted to cover on this, and this notion of there's somewhat unlimited bandwidth to a certain extent, or theoretically, based on your ability to do error correction.
That's correct. Theoretically.
Yeah.
Right.
But it's that true limit that you begin running into, and it's a physics principle.
It's
Literally what you run into.
Yeah, you can use it in quite a few things, but right now it's actually applied a lot more to data communications. But it actually applies to quite a few broadbands. It's a convergence, a sampling methodology of actually understanding how that stuff works, and that's really what it amounts to. There's a lot of stuff to it, and so I'm really shortchanging the heck out of it right now. But
We only
that's
got so
really
much
what
time.
you're bumping up into is what
I'll
you
put some
call
links in the
channel
show
length.
notes and stuff because there was some interesting reading on that, even for someone that doesn't fully understand it or hasn't
It's
studied
fascinating
physics of that
stuff.
deal.
I mean, it's really
Yeah.
fascinating stuff to actually figure out how you're actually coordinating all that stuff, this discrete functions in space, and actually bringing that in. It's really, really cool stuff. It's very groovy.
And it's great for bar bets, as we've had a
Great
couple
for bar
today.
bets. You know, Mathematica and stuff has operations built into it, so you can load it in, send it out, and it's pretty cool.
So another thing that was mentioned earlier, I think Peter had covered this when you were talking to him about
Yeah.
the fact that this is not necessarily new technology that we hadn't already come up with before.
Right.
There just wasn't really a market for it because we are. So what's happened is that confluence of events where we've now shown that wireless has indeed right on that edge of now it's eclipsing the cable plant's going to be left behind if not changed out or brought up with the new technology that we're now talking about with multi-gig. So those two have come together to solve the problem now. But anybody looking forward, they're building new, they're planning for the next 10 years and such. I mean, you're not putting Cat 5e and that stuff, right? If you're going to pull in new cable, you're going more advanced and setting
You're
yourself
at least
up.
looking at 7, 6, 8 a minimum, 7
Okay.
for sure. I mean, that's for certain, absolutely.
Is it fair to say it's last gasp for Cat 5e?
I'd say it's
this
probably a
is-
pretty fair assessment.
We're wringing that stuff out.
I really would, yeah.
Very good.
I'm actually surprised they can do what they can do right now.
But it's nice though, right? And I like the fact that it keeps you from having to change something out unnecessarily because that's a huge thing for a lot of people.
To replace a cable
yeah.
plant? Oh my gosh, yes. I mean, the downtime. I mean, you have to run them in parallel.
How long
right?
have we had Cat 5? In general?
I don't even.
It's over
I can't
25 years
even-
or something,
oh,
isn't it?
Yeah,
I mean, it's
at least, yeah. It's a long, long time.
good
Yeah.
show.
Yeah, are you
You
kidding?
happy?
Absolutely. Fantastic.
All right, guys, I hope you enjoyed it as well. This was a lot of fun putting it together. We got to meet new people that are actually informing a lot of interesting upcoming episodes and stuff that we're hoping to get into, stuff happening within the bowels of Cisco, new alliances that are pushing the limits of things that you can't even begin to understand, or at least I can't, about what we have coming up. And so we look forward to sharing more of that information with you as we go forward. Hey, stay in touch with us. We thank you for watching this one. All our information has been on the screen. If not already, it is right now. Facebook, Twitter is probably the best. Let us know what you think and what you want to see more of. We sure appreciate you watching. Thank you to the crew. Thank you to our guests. We'll see you guys on the next one. I always forget what we're doing on this.
I do too.
I don't know why it
It's
never
like
snuck in.
Yeah.
Snuck in? Sunk in. Sunk in. Oh, look at you.
Look at each other. I thought we were
Oh, we're doing the
camera too.
wide, and then we go. Oh, that's right.
Oh, so we're doing the.
This
doing the
look,
kind
it
of
takes
the
100
fake-
episodes for anything.
Yeah.
Sits.